Welcome back. So most of you probably use cert-manager again to issue maybe a webhook in Kubernetes, but Kubernetes itself also uses TLS very heavily under the hood. And that's what Richard has been working on. Richard works with us for several years at Jetstack and is an expert in Kubernetes controllers. But he was been wondering if cert-manager can help you with issuing certificates everywhere inside your cluster. How about provisioning the cluster itself? So hello, Richard.
Thanks, Marcia. Thank you for the introduction. Can you all hear me?
We can hear you fine.
Good. Okay, so yeah, I'm an engineer at Jetstack, and I've been working on a project which isn't actually currently part of cert-manager, the cert-manager controller, but is one of a number of future spin-off projects where we're exploring how cert-manager might be integrated with Kubernetes and other projects in the future. The code for everything I'm going to demo today is on GitHub, and it's open source, and you can see the link on this slide that I'm presenting now. Let me start my timer. Well, so we asked ourselves, how are certificates, how are keys and certificates used inside the Kubernetes control plane, and how could we make those certificates visible to an external certificate management system? The background to this is that Jetstack have recently been acquired by Venafi, and Venafi have a product called TPP, which allows an enterprise to see all the certificates and other types of machine identities across their organization. So what would it take to make the certificates of the Kubernetes control plane visible inside that management system? The objectives are then for all of the TLS identities in a Kubernetes cluster, we want to be able to see them clearly alongside all the other certificates in our organization. We want some way to enforce a certificate policy. Maybe we want to say that only RSA certificates should be used, or a minimum key size should be used throughout our organization. And we also want to be able to see in one place certificates which may be about to expire, or which are broken in some other way. That's the overview. Well, so my experiment has been to look at a tool called kubeadm, which you are probably all familiar with, and it's the tool created by the Kubernetes team for spinning up Kubernetes clusters. And I'll start by quickly, if I can, summarizing what it does, in particular what it does with certificates. So kubeadm starts, first of all, it can be used to create a multi-node cluster, but the first node it brings up is the control plane node, the one running the API server, the controller manager, the scheduler, etc. And in particular, it creates certificates and keys for all of those components. You can use kubeadm init to do all this for you, or you can, if you need to customize one of the steps in some way, you can run the individual steps using the kubeadm init phase command. So here's an example of using kubeadm init phase certs all, and using it to generate all the certificates and keys for the control plane components. And you can see that what it does by default is to create a self-signed CA certificate. And that CA certificate is the first thing it creates, and that CA certificate is the one used to sign all the other certificates, and also and also for signing the client certificates used in the next phase, a phase called kubeconfig, which produces Kubernetes kubeconfig files so that the kubelet can connect to the API server, so the scheduler can connect to the API server, etc. The API server has this self-signed CA, and when the kubelet connects to it, it checks the presented client certificate and checks that it has been signed by the self-signed CA. So you can do this right now. And if you run these two phases up front and then subsequently run kubeadm init, it will see that the certificates have been pre-created and it will skip those phases whilst continuing with those other parts of the initialization. When you've run those two phases, you end up with a directory tree, something like this, containing a bunch of kubeconfig files, a bunch of private keys, and a bunch of signed certificates. So there at this stage, we've brought up one node, the control plane node. Next, if it's a multi-node cluster, kubeadm will start a kubelet on each of the worker nodes, and it will give each of those kubelet processes a bootstrap token. This isn't a certificate-based authentication, it's a token-based authentication, which gives the kubelet just enough privilege to connect to the API server and for it only to request, to make a request for a Kubernetes certificate signing request. So Kubernetes API has built into it something called a certificate signing request. And it looks like this. You can see for yourself if you use kubectl explain on a cluster. And this API has been in Kubernetes for quite some time, but there's a recent effort to bring this API towards a V1 stable version. I think it has reached that in Kubernetes 1.19. Well, a certificate signing request has a few fields on it, notably or most importantly, the certificate, the PEM encoded, base64 encoded request itself, containing the template of the certificate that is required. It also has a field called signer name, and it has a username field. The signer name is a way for this API to be used both for internal Kubernetes certificates and so that it can be used extensively and by Kubernetes, by components other than the control plane components. The signer name can be a controller watching for certificate signing requests can be configured to operate only on certificate signing requests which have a particular signer name value. And we'll come to that in the demo in a moment. So here on this slide, I've just quickly taken a snapshot of the CSR certificate signing request resources that are present in the cluster immediately after a two-node cluster has been initialized. And you can see that there's one for the control plane and there's another one for the worker node. So that's how kubeadm works normally. That's probably how you've seen it work. So the question was, how would I use kubeadm so that rather than creating a self-signed certificate authority, it would instead allow me the opportunity to sign those certificates using some external certificate authority. So there are two steps that this is a work in progress, but the two steps that I've figured out so far are how to pre-sign the control plane certificates, and then subsequently how to dynamically sign the certificate signing requests created by the kubelets. So pre-signing of certificates was always possible, but it was somewhat fiddly. There has for quite a while been a mode of operation in kubeadm where you can have it create certificate signing. Now I have to differentiate between certificate signing requests as in the Kubernetes API object and certificate signing requests as in the X509 bundles. Well, what you can do, what you've always been able to do is to use kubeadm to create those X509 certificate signing requests. But it was fiddly and it didn't work quite correctly. So I've done some work recently to make this easier. And what I've done is created a new subcommand in kubeadm called kubeadm alpha cert generate CSR. And this is a simple way to create all of the private keys and accompanying certificate signing request X509 files for all of those keys. And when you run it, you get a tree of files, something like this, similar to what we saw earlier, but instead of a signed certificate, you get a CSR file. So that takes care of that. Well, it takes care of it insofar as you've got certificate signing requests, which you can then manually take to your external CA, arrange for them to be signed, and then put in place the signed certificates. And I'll show you in a minute how we've made that a little bit easier. The next part was that we needed a component which would be able to be able to watch for the Kubernetes API certificate signing requests, those created by the kubelet. And to do that these days is fairly straightforward using a library, a framework called controller runtime. A controller runtime project allows you to, well, makes it very easy for you to write a controller which watches a particular API type, and your entry point is something called the reconcile function, which is supplied with the namespace name of a particular Kubernetes API object, and you take steps to bring that to reconcile that object to, in this case, take the certificate signing request, send it off to the Venafi TPP server, and then go back to this TPP server sometime later and download the signed certificate. So with a controller like that, you then have to disable the built-in sign controller, and you do that with a little patch to the controller manager, disabling the built-in CSR signing mechanism. Okay, I think I'm running out of time, so I'll quickly try and show you the demo. This is all available online on the GitHub repository for you to play with and to view the demo yourselves. So let me switch screen. Hopefully this won't take more than 2 minutes. Oh, I'm sorry, I'm getting prompts from Marcia that I've got longer than I thought. I misheard her first time. So let me explain what's going on here. We've got in the right-hand pane a tree view of the certificates and the signing requests as they're being created. So the script that I've just run ran kubeadm alpha cert generate CSRs. It generated keys and CSR files, and then those are now being sent off to the Venafi TPP server. And the TPP server is busy signing those, and we're now picking up the signed certificates. And you can see them appearing in the right-hand frame. Once all those are in place, we set up, we modify the kubeconfig files, injecting in the signed certificate data, And those certificates and kubeconfig files get mounted into a kind cluster as it boots up. The kind cluster starts by running the establishing and running the control plane components on the control plane node. And once that's up and running and the API server is available, we are then in a position to deploy this controller runtime based signer onto the control plane node, at which point it will be able to reconcile the certificate signing requests that are created by the worker node, which joins. So we can see that customize is waiting for the my signer controller to be deployed. And any moment now, it should become available. Yep. And now it immediately sees certificate signing requests in the API server, and it goes through a couple of loops, submitting them to TPP, the Venafi certificate management system, and retrieving them from TPP. Once they're retrieved, they're placed in the status field of the Kubernetes CSR objects. And once they're in the status field of the CSR objects, the kubelet is able to retrieve the certificate, and it takes care of putting that signed certificate in the right place. And it then is able to complete its joining sequence. And I exited too early. This script was designed for recording an ASCII cinema demo, but and it's cleaned up the cluster already. But at that point, you would have been able to log into the cluster and see that the kubelet certificates and all the control plane certificates were signed by the Venafi external CA. One or two other things I should mention. I've documented, if anyone's interested in following this process, the script is really an automated way of running this sequence of steps, which I've described in the repository. But here I've written some narrative around the setting up of Venafi TPP, and you could translate that if you wanted to whatever certificate management platform you're using. And I've added some narrative around each of the steps that the script performs, explaining in some detail the reasons why we run things in a particular order and how the various steps interact. At that point, I think, Marsha, I'm going to finish and invite any questions or else. Thanks for your time, and I'm looking forward to the next talk.
You will be in the next talk. So currently there are no questions in the chat room except one, where to find all this code, which we just sent a link to.
I'm sorry, I can't hear you very well.
Oh, sorry, I forgot to open the channel back to you. So there are no questions at the moment, except one, which is where to find this, which we posted the link inside. So it's all in our cert-manager organization on GitHub. You can find the signer Venafi, it's called, I think.
Yeah, it's on the screen, if you're still showing my screen.
Now I am. So here you go, Alex. Alex also has a second question. Have you ever tried using REST APIs for the CSRs?
I'm trying to think what that means. I'm not sure I understand the question, Alex, and I can't see the chat at the moment. Marsha, can you shed any light?
So client Go to access the CSR API.
Oh, okay. Well, we're using client Go to access the CSR API in this controller, if that's what you mean. So like all the other API types, I believe that client Go contains a generated client set for this API and and a generated set of informers and listers. And I think controller runtime uses the unstructured API, in fact. I think what it doesn't do, there's some, I think there is one thing it doesn't do is allow access to the approval sub-resource. So I haven't talked about this, but there's another step to the CSR signing process. When a CSR API object is created, it has to be approved before it's signed. And that is, in this demo, handled by the built-in controller, the controller built into Kubernetes. But equally, that could be managed by an external process. And we're looking into that as another cert-manager side project. But that does require access to a particular sub-resource, the approval sub-resource, similar to a status sub-resource. But I don't think that's there yet. The person who would know is James Munnelly. He might be busy answering that question on YouTube.
Well, that's the next speaker. So thank you very much, Richard.